Okay, we have here a situation where um, there is a model for the height age of a certain type of a tree. Okay, the rate of increase is proportional. Okay, we need to pick this letter from here. That this is proportional to this. Okay, so I can say that this dh by dt, that is equal to k times 9 minus h raised to power 1 over 3. Now using the given values here, I put this dh by dt as 0.2, okay, and this is going to be k into 9 minus 1, that is 8 raised to power 1 over 3. So this k is going to be zero point 0.1 because the cube root of 8 is 2. So this equation, when I put this k as 0 0.1, so we get this equation, that is dh by dt, that is equal to 0.1 times. So this was really a gift for you, these 2 marks. Okay, now we have to solve this differential equation. Let me make a dabba here so that I can solve it here. Later I'll just remove this. So I'm going to solve this equation for you people. Uh, so this is really a very easy question. dh over 9 minus h raised to power 1 over 3.1 dt. We can easily remove this to the numerator. 9 minus h raised to power minus 1 over 3 dh, that is 0.1 dt. So this is going to be uh, 9 minus h minus 1 over 3 plus 1 is 2 over 3. Its reciprocal is 3 over 2. And there has to be a minus 1 as well. That is the derivative of 9 minus h. Okay? That is equal to 0.1 t and then plus c. Let's use this t0 and height 1 to find this c. So this is minus 3 over 2, and this is going to be, when I put this 1 here, this will be 2 raised to power 2 left here. That is c. So the c is minus 6. So finally this 3 over 2 minus 3 over 2, in fact 9 minus h raised to power 2 over 3, that is 0.1 t minus 6. Okay, so this we have to write h in terms of t. Okay, so this is going to be 9 minus h raised to power 2 over 3, that is going to be 2 over 3 into 6 minus 0.1 t. I have just multiplied this minus, both the sides with minus, so this becomes 6 minus 0.1 t. So 9 minus h is 2 over 3 into 6 minus 0.1 t whole raised to power 3 over 2. Okay? And finally, your h is 9 minus all of this. That is your h in terms of t. Let me write it down here so that I can use this later in the next 2 parts. So this h is 9 minus 2 over 3 into 6 minus 0.1 t. All of this is to power 3. Okay, now we have to find the maximum height. Any idea? Yes? Yeah. Now, there is a problem that we sometimes start thinking about this equation. Oh, we have to use this equation to find that time. So when you find the maximum, whenever the word maximum or minimum comes here in your pure mathematics, or even in your mechanics or statistics, there should be that dy by dx putting equal to 0 should be coming into your mind, okay? That is finding the stationary value. So we shall put this dh by dt equal to 0. So this is going to be the third part. So that is going to be zero point 0.1 into 9 minus h raised to power 1 over 3. When you put that equal to 0, this height is going to be equal to 9. That is the maximum height the tree can acquire, okay? And then it says the time taken to reach this height after planting. So we have this equation now. You put your h9 over here, and then when you put that time, I think the only thing that will be left, that will be 6 minus 0.1 t equal to 0, Hannah? And this 0.1 t would be equal to 6, and t is equal to 60. So that is 60 years. It will take 60 years for the tree to reach the maximum height. Now, I have done this very quickly. When you put this equal to 0, I mean equal to 9, 9 se cancel ho jayega, 2 over 3 will be 0. Only this thing will be left here. Okay? The last part, calculate the time taken to reach half the maximum height. So this means you will put this 9 minus this 2 over 3 into 6 minus 0.1 t raised to power 3 over 2. Sorry, Yani has to be here. 3 over 2. We put that equal to 4.5. Now, mostly people think that if 60 years are taken to reach the maximum height, then there will be 30 years required to reach the half the height. Why this is wrong? Because this is not a linear function over here. This height equal to, in terms of all of this, there is not a linear function. Okay? So you need to solve this equation now.